So the diagram has A, 2, and 4. O is the origin. It will matter later on to know the coordinates of O. So let's put them in. B, 6, and 2. C is a point on the quad that is given here. D and E are midpoints of AC and BC respectively. F is a point on the line DE. And from B, the straight line drawn parallel to the y-axis cuts at the x-axis in T, and triangle angle AOF rather is that angle there. Okay, I'm just going to put this just for the sake of it. Never know, it might pay off later on. Okay, the length of AB, that is probably a question which you will regard as an insult to intelligence, I know, but let us just, for the sake of it, it's 2 marks. So for the sake of it, let us do it. And the length of AB in this case, we'll use the distance formula, and we have that from an information sheet. So that is change in x all squared plus change in y all squared. What do I mean by that? I mean take the x value at A, subtract the x value at B, and then square that. Take the y value at A, subtract the y value at B, square that as well. And then this is 4 squared, which is 16. Now that is what? 2 squared, which is what? 4. Obviously, this is all under the square root. And this happens to be the square root of 20. But we're going to simplify that to 2 square root 5, right? We're going to get 2 square root 5. Or you're not going to bother because the calculator doesn't. Right? Remember, 20 can be written as a product of a perfect square and a non-perfect square. That is 4 times 5 in this case. So square root of 4 is 2. So that's why we have 2 outside. And we have 5 in there. Okay, cool. That is that. Number 1, again, 3.1.1 done. 3.2.2 again. I know you feel like I'm insulting you here, but my apologies. Let's just do this for the online guys. Yeah? All right. 4 minus 2. That is the change in y. Still on the line AB. And then 2 minus what? 6. Okay. This is what? 2 over negative 4. So it is minus a half. And it makes sense for that gradient to be negative. Do you all remember Benjamin? You remember Benjamin? You have forgotten about Benjamin, guys. No, I've heard. That's my best friend. Look, this is what he says. Okay, let me quickly show you how Benjamin looks like. This is what he says. Okay, if a line is increasing, it has a positive gradient. If a line is decreasing, it has a negative gradient. If a line is vertical, the gradient is undefined. And if a line is horizontal, the gradient is 0. You see, that's my good friend. And you will see when we do that. You'll see in calculus, it becomes very useful. I promise you. I promise you. I was doing calculus yesterday, and Benjamin proved to be very useful there. In fact, it was not calculus, functions. And you want us to do functions in the next hour. I'll show you how Benjamin becomes so useful when it comes to functions. Okay, but now because we have upset him, I think he looks like this. And this will be his genuine reaction. It's going to be a bit clumpy. See, that's Super Saiyan. Yes, that's Benjamin. You've upset him now. Now he's going to look like that. Okay, that is that. So all I'm trying to say is you got a negative number here. Now you got to check it. Does it make sense for that thing to be negative? And yes, Benjamin tells you, because this thing is decreasing clearly, the gradient must be negative. Okay, that's all I'm trying to say here. So be aware of this guy. He's a very nice fellow. Look at this. This one is increasing, so the gradient will be positive. You see that kind of a thing. And you see, he's just there. Look at that. The gradient here should be what? Positive. What would be the gradient here? Undefined. The gradient here is undefined. What would be the gradient on the x-axis? There is 0. You see that? Because it's just a horizontal. So that's what he's saying. Okay, let's move on. That was the one question. We're going to move to the second part. And I think that will be question 3.2. So we're going to do 3.2. We're going to prove now. Let's prove that the line OA is actually perpendicular to AB. Okay? And I think we did this in the Euclidean geometry, not Euclidean, but the analytical mixed with the Euclidean. We did that, and we learned that, or we have learned this one in grade 11. So we remember that the angle of perpendicular lines must be what? -1 when multiplied together. So I'm going to write this one because I know you're probably going to write stuff and you're going to expect to get full marks when there's no logic in what you have written. So this is how you must write it. That's how you must write it. First of all, you have to calculate the gradient of OA separately, and then the gradient of AB separately. And then finally multiply them and show that when multiplied they give you -1. Then you can conclude that the two lines are perpendicular. So let's do that. So the gradient of OA, obviously O is the origin. So that will be 4 minus 0 over 2 minus 0, changing y over changing x. That is 4 over 2, which is 2. Then we find separately from that, we calculate the gradient of AB. In fact, we found that in the previous question. Yes. And we know that the gradient of AB is what? -1/2. Now, let's take the product. Now, and actually, I should not even say therefore because I'm still arguing my way through here. So now, the gradient of AB times the gradient of OA is equal to what? -1/2 times 2, which is -1. Now I can conclude, therefore, AB is perpendicular to what? OA. This is the correct way to approach this question.
If OA just from AB is equivalent to -1.
Yeah. Yeah. Well, no. You see, you have to prove. What you are doing is now you are assuming already that they are perpendicular. Yes, and that's what I'm saying. The catch is right there in how you're gonna present your proof. That is where the catch is. So obviously your first mark is in finding the gradient of OA, and the second mark is here, this conclusion here. So that would be definitely a mark, and this will be the second mark. We won't give you mark for AB because you already found it in the previous question, so you have already been prepared for that. Okay, now let's get to 3.3, the equation of DE. DE is that line. Oh, that's where I said I see the midpoint theorem. Do you see it? Now, the midpoint theorem says for us, well, if you are in a triangle and you realize that, yeah, point D and E are midpoints of the two sides respectively, then our conclusion will be what? DE must be parallel to what? To AB. That is what the midpoint theorem says. Not only that, it also says the length of DE will be half of the length of AB. Or you may say the length of AB will be twice the length of DE, if you like. That's what it says also. Okay. So, anyways, all we need to do, or rather what we needed in this case from the midpoint theorem, is the fact that the two lines are parallel. So you see why there was no need to calculate DE. And you see this is 4 marks. I know someone is going to go the long way and try to calculate the point D. But then the question is, do you even have the coordinates of C? No. So you see, that's a mission already. Point E, that's also a mission to try and calculate the coordinates of that point. So it's already, you can't do that. And I know some people become very smart. They try to outsmart us in the exam. You know what they do? They realize the next question is looking for the coordinates of C. So they go to the next question, find coordinates of C, then, but that's not the point here. You do not follow the order, so we may actually penalize you. But
so you're just gonna say 3.4 and then just
yeah, maybe. Okay. gradient of what? AB of D. So it was minus half. So the gradient of DE is what? Minus half. So just like that, we've done. Let me add a page here. So say the gradient of DE is equal to the gradient of what? AB, and that's minus what? Now, let's tell them why before they accuse us, right? So let's tell them why we're saying this. Midpoint theorem. Midpoint theorem, DE is parallel to AB. So that's our introduction. Okay. Therefore, the line DE will have the form negative half x plus what? C. Now you see why they gave us point F. See that? Point F, remember, that is the point actually on the line DE. And that is 6 and what? 9 over 2. So we must substitute. 9 over 2 is the y value, 6 is the x value, plus c. This is calculator work source. 9 over 2 plus a 3. So you got what? 15 over 2. So c is 15 over 2. Therefore, the equation is negative half x plus 15 over 2. Happy with that? Okay, fantastic. Let's move on. The next question then requires us here to calculate, the coordinates, it says, of C. Now, this is an interesting one, such that A, O, B, C in this order that is given is a what? Analytical. So I wanna show you how to have fun with this one. Okay. I know you don't see the fun yet, but my apologies. Let's check this. So look at this now. If A, O, B, C is a parallelogram, if that is indeed true, let me trace it down. That is A, O, B, C. So if this is truly a parallelogram, then here are the implications. Two opposite sides are equal and parallel. But not only that, the diagonals bisect. What are the diagonals here? Is the diagonal AB and the diagonal what? OC. You with me there? So the diagonal AB must bisect the diagonal AB. So in other words, they must share a midpoint. That's what it means. They must share a midpoint. Let's call this midpoint point M. Now, I don't have enough information to find the midpoint OC, but I have enough information to find the midpoint AB. So we can find the coordinates of M. This is now 3.4. We can find the coordinates of M by saying 2 plus 6 over 2. That is, I'm getting the x coordinates of point A and B. And then 4 plus 2 over 2. Okay. Therefore, M is what? Is that 4 and 3? Good. Now, this is time to think backwards. GT. It's time to think backwards. This is how I'm going to think backwards. I'm going to come to the line OC. Now think with me. If I were to calculate that midpoint, the same midpoint M, but this time using O and C, what would I do? I would add the x value at C and the x value at what? At O. And I would divide by what? And that should give me what? 4. That is just the x part. Now, do I know x at C? No, that's what I'm looking for. So x at C, but the x at O is obviously 0. Now, do you see TT? X and C is what? 8. And if you look at the sketch, it actually makes sense because X and B here is 6 and C is further to the right. So that is indeed 8. Makes sense. I see you're excited, so you can find the Y there. Y and C. What is Y and C, Ms. Johnson?
6.
Did you find it? 6. You're not agreeing because it's 7. Okay. Yeah, but obviously you're going to do the exact same thing. You're going to go YC plus Y over 2, but you're going to equate this to a 3. This time around, and 2 times 3 is a 6. So Y and C is a 6. Cool, brilliant. Just like that. We in the money. Now let's get to these 9 marks, the last 9 marks. They are making you sweat here. They want you to do some hard work, but I'll show you it's actually easy work. Let's show you. Where's that thing? I create more space for myself so that we bury this question clean. I'm gonna find it. Things moving the page. Okay, the size of what? Theta. Now, here's something important that I need you to remember. Theta happens to be an angle between 2 lines. The 2 lines are the lines OC and the line what? OA. Right? So, if we want to find an angle between 2 lines, we need to understand, first of all, I must find the inclination for the line AO. I will call that inclination alpha. Then I must also find the inclination for the line, the blue line here now. That is the line OM or OC, if you like. Then we call that inclination beta. Now I need you to see the relationship. Do you see that theta plus beta give me alpha, or must give me alpha? At least, do you see that? So alpha, theta plus beta must make up alpha. But I'm looking for what? Theta. So if I'm looking for theta, then theta will be alpha minus beta. Now, can I find alpha? Yes, it is an inclination. Can I find beta? Yes, it is also an inclination. Which equation are we going to use? Well, here's our magical equation. Tan alpha will be the gradient of, say, OA is correct. OA, that is the first equation. Now, do I know the gradient of OA? It was 2, right? Exactly. So that means tan alpha is equal to 2. Now, arctan of 2 is what? That's your inclination. 2. And round that for me to 2 correct decimal places. What you get? 60? 63 point? Okay, 63.43 degrees then. We do the same thing for beta. Tan beta will be the inclination of, the gradient of OC or OM, same thing, né? And do we know the gradient there? Well, if we don't know it, we should have enough information to calculate it. Are we together? What was M again? Well, we have C. C is 8 and 6. So the gradient is actually 6 over 8. 6 over 8. So, which we can simplify 2 over 3. Now, what is beta? Again, we're going to move for arctan of 2 over 3. What do you get for beta? 3.69. What did I get here?
Isn't that 4? I think it's 2 over 2. 2 over 4.
Oh, 3 over 4. Yeah, sorry. Yeah, I was actually not getting surprised with what did I get here. It's not 2 over 3. Yeah, that simplifying was extremely weird. So, okay. Welcome to Cliff and Ross. Yes, it's 3 over 4. Now, let's do this one. That sounds right. 36, 28, 7. That one sounds very much right. Yes. So that's 3 over 4. 3 over 4. 36.87. Okay, now theta is what? The difference, right? So theta will be 63.43 degrees minus 36.87 degrees. Then the answer there should be at 26.56 degrees. Will you remember this later?
No.
What? That's too negative, guys. Okay. Anyways, you better than okay. It's fine. I'll upload this. And you must go watch it so that you can follow it. Will that help, Miss Johnson? Okay, cool. Right. Now let's wrap up. And we're gonna wrap up by finding the area of the triangle ABT if A and T are joined. Now, remember earlier on, I put up a right angle here. And I said that might actually be useful later. And I think it's going to be useful here. I don't know actually. No, it's actually not going to be useful. I was thinking about it, I have to join A and T. So, I'm going to wrap up everything here. Clear this. And here's my triangle. Without I'm crossing here, he's going to shout at me and say I'm not drawing straight lines. So let me make sure that I perfect this. Yes. Do you see that triangle? Now, I'm going to consider BT as my base. And if I consider BT as my base, do you agree that it will have 2 units? Because it's from T to B, and that's the Y. Now, for me to find the height of this triangle, remember, the height must then be perpendicular to what? The base. Remember that? The height must be perpendicular to what? The base. So, the only way to find the height here, you get that. I'm going to create another line here. This line is actually parallel to the blue line. So, what should be the height? This is 4. This is 6. No, that is 2, not 4. My apologies. I looked at the y-axis, guys. Sorry, my apologies. So the height should be, do you see it? So h is equal to 4. Now we can apply our formula. That's it. Area is what? Half base times height. And I know the base is a 2. I know the height is a 4. Clearly the answer here is 4 squared. Or units squared. Whatever the units are. Must be squared. Okay. Are we fine? Alright. I think we're gonna wrap it up here for this video. I'm not using an analytical. I would like us to now do functions. You guys said 2 topics, right?